Hi everyone. A lot of this unit and what we're going to do later on in the course deals with using percent and equations and applying them to different types of problem solving. You may have in the past used proportion to solve percent problems. That may or may not work for some of these. So I would recommend you learning this equation. What's in this box is the key to success for any kind of percent problems. It gives you the basic equation and then all the information that goes along with it. Okay, so as we look at this box, we see that the equation is very simple. There are 3 blanks in it. Since it's an equation, you're going to know 2 out of the 3 and you're going to have to solve for the third one. You've got percent of something is something. The percent, it will be changed to a decimal before we go into any solving it. This is the original amount, also called the whole or the reference value. To be consistent, I'll probably try to call it the reference value. This is the change, the part, the new value, but also the compared value. So we have percent of the reference value is the compared value. Now as we're reading, math is kind of a foreign language. The word of in English means multiply in math, and normally in the equation we will put it in parentheses. The word is means equal, and of course we'll have an equal sign there. Okay. So you'll see at the bottom here, this translates to something times something equals something. Okay. All right. Now, once again, if you have 3 blanks, 2 of them are going to be in given to you in numbers, and the third one is what you're going to have to find. Okay. The key to this is noticing that the decimal or the percent here and the compared value relate to the same thing. This is as a number, this is as a percent of the reference value. Okay, so let's look at the first problem here. Students examine 140 vehicles in a school parking lot and find that 15% of the cars in the sample have oil leaks. How many have oil leaks? Okay, well, the thing that these have in common that represent the same thing is oil leaks. We find that 15% have oil leaks. So 15%, this gives you the oil leaks as a percent. And then it asks how many cars have oil leaks. Whoa, my pen cap got away from me. Cars with oil leaks. So this is our oil leaks as a number. So that means that our reference value is the 140 vehicles. So this is the cars in the parking lot. Now you will notice that also in here it says 15% of, just exactly like it says here. So 15% of the cars in the sample. Okay. So this is just an intermediate step. This is where we take the information and turn it into the appropriate form, and now we're going to turn it into an equation. This percent has to be changed to a decimal. And we remember that 15%, cross that off, move it 2 places to the left, so I have 0.15. The cars in the parking lot, there are 140. What they want to know is the number of cars with oil leaks, so that's going to be our variable. And we'll just replace that with an x. Okay, so now we just solve for x. So I have 0.15 times 140 is equal to x. Remember, when you're solving an equation, that means you want to isolate the variable. You need to know what the variable is equal to. Since the variable is already by itself on this side, you can just multiply here, and 0.15 times 140 tells you that x equals 21. So to write your answer in a complete sentence, there are a lot of ways that you can do this. You can say that 21 cars have oil leaks. Because that's what they want to know. Okay. Now, notice there are 3 blanks, so the variable can be in either one of these. So that's the sample that we're going to do in class, is we're going to give you one of each kind. Okay, so our next one here, Mark has earned 75% of the credits that he needs to earn a degree in pre-health sciences. Let's look at this sentence. We've got a percent, 75. Well, 75% of what? Of the credits he needs to earn the degree. So I'm going to abbreviate that. So 75% of the credits needed. And then the things that represent the same thing are the credits earned. So this is going to be as a percent, and this is going to be as a number. Well, in this particular one, so this is going to be credits earned. So Mark has currently earned 48 credits. Now look also what they want to know. How many credits are required? That's what they want to know. So that's going to be our variable. We're going to take the 75% and change that to 0.75. The credits needed, that's what we're looking for, and the credits earned, he has 48. So now we solve this. So I have 0.75x, or times x, is equal to 48. Okay. In this particular one, the x is not by itself, so I have to get what is that x equal to. Well, if I have x multiplied by 0.75 to get rid of this, the inverse operation of multiply is divide. So I'm going to divide by 0.75. Whatever I do to one side, I have to do to the other. Why am I doing this? Because anything divided by itself is 1. So what I'm left with here is now x is equal to 48 divided by 0.75. If it's helpful, write it as 48 divided by 0.75. And when I put that in my calculator, I get that x is 64. I think that's right. Yes. 64. Okay, now let's think about this. Is it reasonable? Okay. Well, we know he doesn't have all of his credits earned, so we know that this number needs to be less than this one. 48 is less than 64, so that works. Okay. So it has to be more than 48. It has to be less than 64. 75% is more than 50%. So if you go back to your benchmarks, 50% of 64 is 32. So again, from both the top and the bottom, this is reasonable. Okay, so to write it as a complete sentence, Mark needs 64 credits to earn his degree. Okay, during a promotion, Amazon reduced the price of an iPad mini by $56. The original price was $224. What was the discount percent? Okay, so we're looking for the percent here. But we're looking for the percent of the discount. So since this is the discount as a percent, what we're going to need over here is the discount as a number. Well, let's see here. It says they reduced the price of the iPad by $56. So this is our discount. Okay. Well, the discount, the reference value is going to be the original price. So we know where everything belongs. But in this particular situation, this is what I don't know. So that is where my variable goes. It tells me that the original price is $224 and the amount of the discount is $56. Okay. So if I solve this now, I have x times 224 is equal to 56. Once again, my goal is to get this variable by itself. It is multiplied by 224. To undo that, do the inverse, which is divide by 224. Whatever I do to one side of an equation, I have to do to the other. So that becomes 1. That gives me just 1x or x. So x is 56 divided by 224 in your calculator. So x is 0.25. Now, if I were to put that answer down, I would get some points taken off because this has to be converted to a decimal. To a percent, excuse me. Because that's what it asks. What is the percent discount? So of course I know to do that, I take this and move it 2 places to the right, add the percent sign, so x is equal to 25%. And then you can just write your complete answer as the discount was 25%. Okay, then we moved on to the problems that you and your groups were going to work together. All right, so in your groups, the first problem, a survey revealed that 48% of employees take their lunch to work. Okay. All right, so let's figure this. 48%, of course, that's our percent, but 48% of what? Of employees. Okay. So the reference value, the of number as I call it, is employees. Our percent is 48%, and this is 48%. They want to know how many take their work to lunch. Okay, so these are employees who take their lunch. As a number and as a percent. Okay, well we know the percent and we have to convert that to a decimal, so that's 0.48 there are 200 employees, and they want to know how many take their work to lunch, so that's going to be our X. So now when I solve this, I have 0.48 times 200 is equal to X. Since the X is already by itself on one side of the equal sign, we just have to multiply this, and X is equal to 96. Okay, so is our answer reasonable? Well, 48% is very close to 50%. So 50% of 200 is just half, is 100. 48% is just a little bit less than 50%, and 96 is a little bit less than 100. So my answer is yes, it is reasonable. And written in a full sentence, let's see, 96 employees take their lunch. Okay, our next one. At a restaurant, you want to leave a tip of 20% of the cost of the meal. If the amount of the tip is $7.20, how much was the meal? Okay, well, I've got a percent. 20%. Of what? Of the cost of the meal. Is the tip. So we've got the tip as a percent, and we're going to have it as a number. Okay, so let's see which of these, how much was the cost of the meal? So we know that that's where our variable is going to go. We know our percent as a decimal is 0.20, and the tip as a dollar amount, the tip is $7.20. Okay, so I have 0.20x is equal to 7.20. Once again, my goal when solving is get the variable by itself, find out what it's equal to. Since it's multiplied, to undo multiplication, I divide. So x is equal to 7.20 divided by 0.20, and you get that x is 36. Okay. All right, so I'll leave you to figure out how you determine reasonableness. I just took 20% of 36 is 720, so that actually works. So the question was, how much was the meal? So the meal, the cost of the meal, was $36. Okay, I'm going to switch videos and then we'll finish this up.